Good morning, students. Before you is your teacher, and I'm going to take you through a topic that is very important to us, the topic of loci. Now, this our topic of loci. I want us to take this our first lesson to understand the 6 key types of loci. And remember, loci is just the plural form of the word locus, which means a path. So in this our topic, we are simply going to trace paths that a particle will take round a point, along a line, or in our 6th type, I'll explain another type of locus that will entail the inequalities. I want us to start with the first type of loci, which I call the locus of points equidistant from a point, or the path followed by a point that the point will remain at equidistant away from the point P. So I have my point P, and I want to walk around this single point P such that I maintain same distance, or what I call equidistant. So if you want to walk around point P that you maintain same distance around P, then you walk at a distance D constantly around the point. And if you do that, you realize that the locus of points around a point is just the circumference distance d centimeters around the point. So I call that locus the circumference. This is going to be my locus. 2, I have the locus of a point equidistant from a fixed line. So in this case, I want us to take my line to be line AB. Line AB. How do we walk such that we remain at same distance, which I call equidistant, away from this single line? Then you'll have to measure a constant distance d centimeters. And then you will walk d centimeters away from line AB. And therefore you can walk above line AB, or you can walk below line AB, but you maintain a constant distance d centimeters. This is my d centimeters above or below line AB. And therefore the locus of point equidistant from a fixed line is a parallel line on either side of line AB. So it can be up or it can be below, but the distance the two parallel lines are above or below line AB is a constant distance d centimeters. My third type of locus, I call it the locus of a point equidistant from 2 points. So I have 2 points here, point A and point B. For me to have a path that a point will remain same distance from point X and Y, a path that somebody would want to walk so that it remains same distance from point X and Y, then I join X and Y. I join point X and point Y. So I've joined the two. Then I simply bisect this my now line X, Y. So I'll stand at X, make an arc, Y, then I join the two. Along this path here, which I call the locus, a particle will remain same distance away from point X and Y. And therefore this locus is simply perpendicular bisector of line X, Y.
My fourth type of locus, I call it the locus of a point from two intersecting lines. So I have two lines here intersecting. Line AB is intersecting line CD at point O, or line OD is intersecting OB at this point here. The word intersecting here simply means they meet. So OD and OB meet at point O. So you want to get the path or the locus a particle will take such that the particle will remain same distance away from line OD and OB. Then it is simply this angle bisector. There is an angle here. There's an angle here. You can even call it angle theta degrees. You bisect it, then the bisector there will be the path that a particle will remain at same distance from line OD and OB. Or OC and OB, the locus will be this. So along this path, the particle remains same distance from line OC and OB. And therefore, the locus of a point from two intersecting lines is the angle bisector. My fifth type of loci, I call it the constant angle loci. And this constant angle loci is borrowed from Form 2 work. And this is what it says. That since we have a chord AB, chord AB will subtend an angle at the center, which is twice the one subtended by the same chord at the circumference. So I want to illustrate this my locus by indicating here to be 2x, and therefore the angle at the circumference is x. And remember, triangle AOB is an isosceles triangle with the base angles equal. These two base angles are equal. And therefore, for me to construct an angle in the major circumference that remains constant, then I'll concentrate on this angle at the base of the isosceles triangle. I'll construct this angle and this angle. And then my line of construction will be extended. And also my line of construction on this other side will also be extended. Where the two meet, where the two lines meet, I'll stand at this point, adjust my pair of compasses to A, then I construct my locus. So this is my locus. Any point along this locus will give me equal angle. That's why I've said that angle AXB is equal to angle AYB is equal to angle AZB, which are all constant, and it is x degrees. And therefore the constant angle loci is a knowledge of Form 2, and we concentrate majorly on the base angle of the isosceles triangle formed by the chord AB and the center forming that isosceles triangle AOB. So when you construct this angle, extend that line BO, extend line AO, where the two meet, stand there and have your constant angle. I'll give an example showing constant angle loci. And therefore, constant angle loci is part of the circumference that form constant angle with the line AB. This line AB, in my case, I call it chord AB, but it can be another chord according to the way the question is framed. Lastly, I want us to concentrate on locus of inequalities, which is also a knowledge borrowed from Form 2 work. I have 4 examples of inequalities here. X is greater than 2, 4y plus x is less than 28, y is greater than 2x minus 9 and 3y plus 2x is greater than 3. When you plot and draw these four inequalities, you will have the required region R. For instance, when you draw the graph x is equal to 2, it is this graph here. And because the inequality is greater, you will shade your left side. Plus, these are the inequalities. 3y plus 2x is greater than 3. And then, the other one here is y is equal to 2x minus 9. 4y plus x is equal to 28. Then you will remain with the required region R. Therefore, the locus of inequalities or loci of inequalities is simply describing the region that is left, clearly left and seen by the inequalities that you are asked, the inequality graphs that you are asked to plot and draw. And therefore, the loci of inequalities is the required region R, as I have indicated here. Thank you very much, and these are our 6 major types of loci. And after this, our lesson here, in our next lesson, I would want us to go practical with examples. Thank you.